Alright, so now we're going to do the laboratory exercise number 7. The title is IP addressing exercises. So first we have to convert the following IP addresses to binary numbers. First is 201.17.29.4. Okay, so for this we have to subtract each of the numbers to 128, 64, 32, 16, 8, 4, 2, and 1. If in case it's not, or if the number cannot be subtracted by those numbers, we will put 0 until we have 1. Okay, so let's begin. Alright, so I've already written down 128 to 64 until 1. So first, 201 minus 128. So that's gonna be 73. You have to put 1 here. Now 73 minus 64. That's going to be 9. So we'll put another 1. Now 9 minus 32, of course, cannot subtract that, so we're gonna put 0. 9 minus 16 is 0. 9 minus 8, we're gonna put 1. 1 minus 4, 0. 1 minus 2 is 0. 1 minus 2, and 1 minus 1, we're gonna put 1. So this will be our binary for 201. We'll do the same thing with 17. Okay, so 17 minus 128, we're gonna put 0. 17 minus 32 until 17 minus 64, so that's going to be another 0. 17 minus 32, another 0. 17 minus 16, we're going to put 1. 1 minus 8 is equal to 0. I mean, not equals, but we're going to put 0. So just when I say 0, that means that's the one I'm gonna put in, but that doesn't necessarily mean that it's the answer. Okay, so 1 minus 4, we're gonna put 0. 1 minus 2, we're gonna put 0. And lastly, 1 minus 1, we're gonna put 1, because you can subtract that. Okay, now we're down to 29. So again, 29 minus 128, we're gonna 0 that. So 29, that will be, we're gonna put 0 until 32. 0, 0. So 29 minus 16, it's gonna be 13. So 1. 13 minus 8, 1. 5 minus 4, 1. 1 minus 2, 0. 1 minus 1 is 1. And lastly, number 4. So this will be 0 until the number 4. 0, 0, 0, 0, 0. 4 minus 4 will be 0, so that's going to be 1, and then 0, 0. So our binary will be for 201.17.29.4, that will be 110.0.1.0.0.0.1 0.0.0.1.0.0.0.1, and for 29.0.0.0.1.1.1.0.1, and for number 4 0.0.0.0.0.1.0.0. Okay, so let's go to the second IP address, 192.168.1.1. Okay, so first let's go with 192. So 192 minus 128, we're gonna put 1 for that. 64 minus 64, we're gonna put 1 more to that, and the rest will be 0. Zero, 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 0, 0, 0. Okay, so now for 168, minus 128, we're gonna put 1 to that, and then the answer will be 40. 40 minus 64, we're gonna put 0. 40 minus 32, we're gonna put 1. 8 minus 16, we're gonna put 0. 8 minus 8, we're gonna put 1. And since we no longer have anything, we're gonna put 0 the rest. Okay. All right. So now we got 1. So everything should be 0 until we get to the last part. Since this is 192.168.1.1, we'll just do the same. 0, 0, 0, 0, 0, 0, 0, 1. So the binary will be 110, 0, 0, 0, 0, 0, 0. Well, you can see it here. This is what we have. Okay. So this will be the first number preceded by the second set of numbers. This will be the third, and this will be the fourth series of numbers. Okay. We're gonna do 172.0.0.0. So 172.0.0.0. So 172 minus 128, we're gonna put 1. Then 44 minus 64, that will be 0. Then 44 minus 32, we're gonna put 1. 12 minus 16 is 0. 12 minus 8 is 1. 1, we're gonna put 1. And the answer for that will be 4. So we're gonna subtract 4 to 4. It's gonna be 1, and the rest will be zeros. Okay. So since we have 3 zeros here, that should be 0 as well. 0, 0, 0, 0. Okay. So those are circles. Okay. Alright, so this will be my answer for 172.0.0.0. So everything will be going 0 after the 172. Okay, so now we're going to do the second procedure here. We have to convert sets of binary numbers to decimal number. Okay, so first is 110 0 1 1 1 1. Oh, sorry. Let's try to make it bigger. 1 1 0 0 1 1 1 1. Okay, so our answers will be on the left side. Let me write the numbers first. Okay, 5 zeros. 1 2 3 4 5. 1 2 3. Then 0 0 0 1 1 0 1 0, and lastly 1 0 1, all zeros. Okay, so just for us not to be confused, you have to make sure that the numbers are aligned to each other so that it will not be mixed up. Okay, so on top we're going to add again 1 2 4 8 16 32 64 128. Okay, so we're going to add all of the numbers that has 1. So for this one it's 128 plus 64 plus 8 plus 4 plus 2 plus 1. Okay, let's put them on column. 128 64 8 4 2 8 plus 4, 12, 20, 24, 26, 27. Four, it's gonna be 10. So the answer for the first one is 207. Okay, we're gonna do the rest. So for the second, binary numbers should be 4 plus 2 plus 1. 4 plus 2 plus 1. So that's gonna be 7. For a third one, plus 8 plus 2. 16 plus 8 plus 2. 16. So it's gonna be 26. And the last number is 128 plus 32. 128 plus 32. 6. 160. So our answers will be 207, 7, 26, and 160. Okay, so now let's proceed with number 3. So it says here network address 192.168.1.1. Subnet mask is 255.255.255.a. Okay, so what is the network address in binary? So we have already answered that a while ago. Those are actually given on the second or the first question. So 192.168.1.1. So it should be 110.0.0.0.0.0. 101.0.1.0.0.0 and 0.0.0.0.0.0.0.1 and same thing. So that's going to be the answer for network address in binary. Okay. So now for the subnet mask, 255.255.255.a. Okay. So first we're gonna write again 128, 64, 32, 16, 8, 4, 2, and 1. Okay. So 255 minus 128. We're gonna put 1 on that. 127 minus 64. We're gonna put 1 on that. 63 minus 32. Gonna put 1 on that. And 31 minus 16 under 1. Then 15 minus 8. We're gonna put 1. 7 minus 4. We're gonna put 1 again. 3 minus 2, 1. And 1 minus 1. So actually it's everything is all 1. So since it's 3 consecutive same numbers, 255.255.255.255, we're gonna repeat the same numbers. So everything is actually 1. So this will be times 3. Now for the letter, so A, the ASI code for that is 65. So from there, A is equals to 65. So let's start with 65. 65 minus 128. We're gonna put 0. 65 minus 4, 1. And we're gonna put zeros on all of them until 1 minus 1, because we have a remainder of 1. Okay. So the binary of the subnet mask is all 1s. You have to repeat it 3 times. And for A, it's 0, 1, 0, 0, 0, 0, 0, 1. Okay. So the prefix length will be 24. And in the network IP address, 192.168.1.1. I'm sorry, not 24. Yeah, that's 24. Yeah. 192.168.1.1. The network portion, we have to underline it. So it should be 192.168.1. And the host portion should be the last, which is 1. Okay. Okay. So now we're going to answer the 4 questions stipulated on the laboratory exercise. So number 1 is, why do we need to convert the decimal value into binary numbers? Well, of course, our computers can only understand binary numbers, and so that's the reason why we have to convert it to binary. It's like our letters, but the computers will only understand binary numbers. Number 2, why all computing devices have an IP address? Is it possible to have a similar IP address among end devices? Explain your answer. Well, in a network, it is imperative that a particular device has a unique IP address, but you can have the same IP address as long as they're not on the same network. We're talking about the local IP addresses. If the IP addresses are the same, what's going to happen is we cannot the router cannot properly identify the particular device, and so this will cause mayhem or confusion within the network. There's going to be a problem with how we identify the end devices. It's like your house. if you have the same address with a different house, there's going to be a problem because nobody's going to be able to deliver. Or if they're going to deliver something in your house, it might going to be delivered on the other house, not yours. Number 3, what is the importance of Subnet Mask? So Subnet Mask is the way on how we can classify a particular IP address. This is actually important so that we could identify what kind of IP address we have. And what can you conclude from this activity? So, well, this activity gives us a brief introduction on how our text that we input on our computers are being translated to the how the computer understands those things. So if you put letter A, or if you put series of numbers, that is translated to binary numbers. It is important that we know, most especially if we're doing troubleshooting. So yeah, that will be it right now. Have a great day.